Now the next example we are going to see here. The next example we will see here is another. See, these are two codes. I have written the same code in two different ways just for comparison. You look at the thing here. Now instead of a mux, we are looking at a demultiplexer. So this is the demultiplexer, right? Here we are going to use the power of our blocking assignments. I'm going to assign all the outputs to 0 because what is the function of a demultiplexer? Tell me. Whichever in case of a demultiplexer, what do we want? In case of a demultiplexer, what do we want? All the outputs are going to be 0. Correct. All the outputs I have y0, y1, y2, y3, so on, multiple outputs. Say for example y. So now I have input. Now depending upon my select, one of these is going to follow my I. Remaining all are going to be zeros. Correct. So now the same thing is what is going to happen here. I am going to use my blocking statement here. So I assign all the outputs to 0. Y int is my output. So that in case of the multiplexer, I formed a I int. Here I am forming a Y int. And I will assign all the outputs based on Y int. This is just an assignment statement. So I have output O1 to O0 to O7 and input 3-bit select and an input called I. Now this input I needs to be routed to one of these outputs depending upon the select line. So let us see. I have created y underscore int and I am assigning that to the outputs. Now what is y underscore int? Let's look at it. I am assigning y into zeros. That means this is like an initialization statement. They are initialized to zeros. The advantage of writing this is it will avoid inferred latches also when you are writing case. Okay, this is a very, very important step. Please pay attention to this. So y underscore int is 8 tick b0. Now, if my select line is 0, then y of 0 is I. If my select line is 1, y of 1 is I. If my select line is 2, y of 2 is I. If my select line is 3, y of 3 is I. If my select line is 7, y of 7 is I. This is exactly the demultiplexer. There is nothing wrong about it, but this is looking good for us 1 cross 8 demultiplexer. Let's say you want to create a 1 cross 256 demultiplexer. You have to create 256 lines of code here. Now if the same thing, look at this. Let me put the line numbers here. See, the code runs for 20 lines. Here the code is running hardly for 13 lines. The code is running for 20 lines here. The same thing I'm going to write here. The code is running only for 13 lines. And the beauty is the code will run for only 13 lines even if you make it as a 251 cross 256 demultiplexer also. That is the beauty. Whereas when you make this as a 1 cross 256 demultiplexer, this code will run for say 270 lines or so. Correct, because 256 lines will come for this alone. This case statement itself will run for 256 lines, and apart from that, another 10 lines of these codes. So I'm saying 270 lines of code because of that. Correct. So if you see here, let's see what this code is doing. What this code is trying to do, this is exactly same here. Till here, the code is same in both the cases. Now you are assigning to 0. Now what you're trying to do, whatever is the value here, the same index is what you're assigning. Correct. So if k, so you run a loop k equal to 0, k less than 8, k plus plus. If k matches select, y of that k is I. So when select is 0, y of 0. When select is 1, y of 1. When select is 2, y int of 2. When select is 3, y int of 3. Correct. So when select is matching with k, so I have to run till all the indexes. Wherever the select is going to match the index only at one place, there you assign the value of I. That is what this for loop is trying to tell you. So let us simulate both this waveforms and check. Again, I'm going to do only the functional simulation here. I'm not going to synthesize this code. I leave that as an exercise to you. Okay. So I want you guys to try out the synthesis and synthesis simulation also. So let me try out I-Verilog dmux underscore case dot v. The TB name is same, TB underscore dmux underscore case dot v dot slash a dot out. Okay, and gtk wave. Let's see what we are getting here. So again, this clock is a in test bench signal. Don't worry about that. Yeah. So we have brought all the signals here. If you see, this is my I. My I is changing like this. I'm going to make select as a say decimal. So now you see this is my input. Let me plot my input in a different color. So this is my input. Now you see when select is 0, when select is 0, exactly O0 is following the I. O1, O2, O3, O4, O5, O6, O7 all are zeros. When select is 1, the output is for output 1 is following the input. When select is 2, output 2 is following the input. When correct, exactly. So whenever whatever line is selected by the select, that particular line follows the input. Remaining all are at zeros. This is exactly the function of a demultiplexer, correct? So this is the waveform what we simulate. This is the waveform simulated for the case. Now let us look at our generate also. Our generate should also yield the same result, right? Let us verify that. So let us get the VCD file for our generate case. So dmux underscore generate tb dmux underscore generate. Actually, it's generate is a wrong name here. It should be for, but okay. We understand for generate and for are two different things. So let us proceed. TK wave. This is exactly the same thing we are getting this for the generate case also. This is exactly the same thing. So if you see here, making the data format as a decimal, and I change the color of my input. If you see here exactly when select is 0, O0 is following I. When select is 1, O1 is following I. Remaining all the outputs are 0. When select is 4, O4 is following I. Remaining all the outputs are 0. This is exactly what we anticipated and this is exactly what we are getting. But the beauty is we got this in a very, very elegant way. The code becomes very, very elegant. Okay, that is the beauty. Okay, this simplifies the coding effort a lot. Okay, so again, synthesis wise, you guys try it out and try out the simulation for that synthesized netlist also. That's the GLS as well. Okay, so this is for the for loop part, which is different from for generate. I repeat it, for generate is for replicating the hardware. For loop is for creating a simplified code. Okay, don't mix these two.